Hi there! In this video, we're going to learn how to solve a distance, rate, and time problem using a linear equation. So what does that mean? We're going to look at story problems that deal with distance, rate, which is the speed, and time. And we're going to use a chart to help us organize all the information that the story problem gives us to write and solve a distance, rate, and time problem, or a distance, rate, and time story problem. So there's basically four kind of general steps to do these. So the first thing that you want to do is draw a picture. These kinds of problems usually involve two objects traveling. So two trains are leaving, or two boats are leaving, or two cars are leaving. So you want to draw a picture to get an idea to help you visualize what the story problem is telling you, but it will also help you fill in your chart, which is step number 2. So step number 2, we're going to make a chart with the given information and the information that we infer, or that means the information that I figure out based on the information that they give me. And so your chart's always going to look something like this. It's going to have a distance column, a rate column, and a time column. And then you're always having two objects like I stated earlier. So here's where you would put some information for your object 1, and here's where you would put information for your object 2. Then we're going to write a general equation, and then we're going to solve. So I have 3 different examples for you because there's kind of 3 different types of these kinds of problems. So hopefully this will help give you some better understanding of how to do these story problems because they can be kind of tricky. And I did type them out just because my writing is big and I didn't want the whole story problem to take up the whole screen. So we're going to read it first and then we're going to draw a picture and make our chart. So this says 2 trains leave the station at the same time, one heading west and one heading east. Whoops. The eastbound train travels at 90 miles per hour. The westbound train travels at 110 miles per hour. How long will it take the 2 trains to be 560 miles apart? So when I'm doing this, first thing I'm going to do is draw a picture. So don't laugh at my pictures. They're not the best. So this is my train 1. And this is my train 2, my eastbound and westbound train. So this is going to be my westbound train. This is going to be my eastbound train. And they leave the station at the same time, one heading west and one heading east. Okay, the eastbound train travels at 90 miles an hour. And the westbound train travels at 110 miles per hour. Okay, so far I've just used eastbound goes at 90 miles an hour, westbound 110 miles an hour, and they leave the station at the same time. Okay, so that's the information I have so far. Last part it says is how long will it take the 2 trains to be 560 miles apart? So that means from here all the way to here, I want to know when is this going to be 560 miles? Okay, so let's figure out a couple things. So let's write a chart out. So I have my eastbound train. So I'm going to write eastbound train and westbound train. And then I have my distance, my rate, and my time. Okay, so there's my chart. Now let's fill in some information. So easy thing to fill in first, I have my eastbound train traveling at 90 miles an hour. Whoops, 90, and westbound traveling at 110. Okay, so here's the part that I have to really think about. My westbound train is going to travel some distance that we don't know. So I'm going to write distance westbound. My eastbound train is also going to travel a distance that we don't know. So this is going to be distance eastbound. Now, I know that my westbound and my eastbound distance total have to be 560. It tells me that my trains leave at the same time. So that means they leave at the same time. And once this distance, the trains are 560 miles apart, the trains are going to stop. That means that their destinations have been reached. So I want to know how long that's going to take. So that means that my westbound distance plus my eastbound distance have to equal 560. Okay, the other thing that we haven't talked about yet is the time well, we talked about it, but we haven't put it in our chart, that the time that the trains travel. We said that the trains, they leave at the same time, and then once they reach 560 miles apart, that means that they're stopping. So the time that they travel is the same amount of time. So we don't know how long that is, but we know that it's the same amount for both trains. The other thing that we know is that distance is equal to rate times time. So I can use this rate times time for my eastbound train and say that the distance that that train travels is going to be 90x. I can use this information, my rate of 110 and my time of x, to say that my distance, because distance is equal to rate times time, I multiply my rate and time together, and I get that my distance for my westbound train is 110x. Now I can take this information and I plug it in my equation that I wrote. So my distance of my westbound train is 110x. The distance of my eastbound train is 90x. Now I can solve. I'm going to put a line down the middle. I'm going to combine together my like terms. 110x plus 90x is 200x. Equals 560. I need to get x on a side by itself. So I'm going to divide both sides by 200. And I get x is equal to 2.8. Which means that it took 2.8 hours for my trains, my eastbound and my westbound train, to be 560 miles apart. Okay, next. Two cars leave towns 800 kilometers apart at the same time and travel toward each other. Okay, so here's my car. This guy is going this way. And here's my other car. And this guy is going this way. Okay. One car's rate is 14 kilometers per hour less than the other car's. Okay, so it doesn't tell us what our rates are. So let's say that this car's rate, we'll call this car 1 and car 2. Okay. We'll pick car 1. Car 1's rate is 14 kilometers an hour less than the others. So if car 1 has a rate of X, that means that the other car is slower by 14. And we know that you subtract 14 because of the speed. If, say, the one car is traveling at 25 miles an hour, if the other car was 14 miles an hour slower, that means I'd have to take away 14. So that would be my speed. So this is kilometers per hour and kilometers per hour. Okay, if they meet in 5 hours, what is the rate of the slower car? All right, so let's see here. So I have my car 1 and my car 2. Whoops. And I have a distance, a rate, and a time. Okay, so car 1, we said that has a rate of X. And car 2, we says has a rate of X minus 14. Okay, if they meet in 5 hours, so that means both cars are driving and they're both driving for 5 hours. So that means that their time is the same and their time is both 5 hours. Now, it did tell me in the very beginning that two cars leave towns 800 kilometers apart. So that means that these distances here is 800 kilometers. Okay, now, same concept as last time. Car 1 is going to travel some distance. Car 2 is going to travel some other distance. And total together, their distances that they travel are going to equal 800. So I'm going to use my same equation that I did last time. Distance of car 1, oops, let me make that a property. Distance of car 1 plus distance of car 2 is going to equal 800. Okay, now I have to figure out what is my distance of car 1. Well, I remember that distance is equal to rate times time. So to find the distance of car 1, I take these values and I multiply them. 5x. To find the distance of car 2, I take these values, oops, let me bid a different color. I take these values and I multiply them. 5 times x minus 14. Okay. Now I can fill in the information. This is going to be my distance for car 1, and this is going to be my distance for car 2. So I'm going to write in here 5x, and in this spot I'm going to write 5 times x minus 14 equals 800. Now, to solve, first thing I have to do is distribute this 5. So I get 5x plus 5 times x is 5x, and 5 times negative 14, you're welcome to use the calculator, is negative 70. Okay. Next, I'm going to combine together my like terms. Here I have 5x's and here I have 5x's. That together makes 10x. Okay, now to get x on a side by itself, first thing I have to do is add 70 to both sides. So I get 10x is equal to 870. And finally, I'm going to divide both sides by 10. Oh, I'm going to run out of space. And I get x is equal to 87. Okay, so if x is equal to 87, and that would be kilometers per hour. It asked me what is the rate of the slower car. So that means that car 1, we said was x, moves at 87 kilometers per hour. For car 2 over here, their speed is 14 less. So they're going to be the slow car. So I have to take this 87 and I'm plugging it in here to figure out the rate of my slower car. So I have to say that this is 87 minus 14, which gives me 73. So that means that my slow car, car 2, is equal to the slow one, is equal to 73 kilometers per hour. Final answer. Okay, let's do one more problem. Rebecca drove to the mountains last weekend. All right. There was heavy traffic on the way there, and the trip took 12 hours. When Rebecca drove home, there was no traffic, and the trip only took 8 hours. If her average rate was 20 miles per hour faster on the way home, how far does Rebecca live from the mountains? Okay, first step, draw a picture. So mountains, I guess that kind of looks like a fire. Good enough. Okay, and Rebecca drove in a car to the mountains. Okay, so, and I'm going to make a chart. So we have to the mountains and home, and we have distance, rate, and time. Now I know I said there's usually 2 objects traveling, and this problem doesn't have 2 objects traveling. So the 2 things that we're looking at are the distance and the speed to the mountains and on the way home from the mountains. So the 2 different time frames or like times that she traveled. Okay. So let's see. Rebecca drove to the mountains last weekend. We got that covered. There was heavy traffic on the way there, and the trip took 12 hours. So to the mountains, there was heavy traffic, and the trip took 12 hours. Okay. When Rebecca drove home, there was no traffic, and the trip only took 8 hours. So to go home, it took 8 hours. Okay, we got that part. if her average rate was 20 miles per hour faster on the way home. So we don't know her speed on the way there. But on the way home, whatever her speed was, it was faster, plus 20. How far does Rebecca live from the mountains? All right, now, this one is set up a little bit different. We still are saying that distance is equal to rate times time. So if I want to figure out what goes in this blue box, I multiply the rate and the time. So this would be 12 times x. If I want to figure out what goes in this orange box, I multiply this rate and this time. So this is going to be 8 times x plus 20. So the last two problems that we did, we said, okay, well, the two distances added up together have to equal the total distance, like between the two cars or between the two trains. This time, the distance that Rebecca lives from her house in her car, she's traveling the same distance. It just takes longer because there's traffic. So I know that the distance to the mountain is equal to the distance home from the mountain. One just took longer than the other. So now, the distance to my mountain is going to be represented by my blue box. And the distance home from my mountain is going to be represented by my orange box. So I can write this equation, and this says 12x equals 8 times x plus 20. Okay, so to solve this, first thing I have to do is distribute, and I'm going to put a line down the middle. I'm going to give myself a little more space here. Put a line down the middle and multiply. 8 times x is just 8x, and 8 times 20 is 160. Now I need to get x on the side by itself, so I have to take this 8x and I have to move it over to the left-hand side. To do that, I'm going to subtract 8x from both sides. So I get, 4x is equal to 160. To get x on the side by itself, I'm going to divide both sides by 4 to cancel out this 4. So I end up with x is equal to 40. Okay, now let's make sure we know what the question is. The question says, how far does Rebecca live from the mountains? So the distance to the mountains and the distance home from the mountains is the same distance. So it doesn't matter if I plug this x in to this blue equation or this orange equation. So you get to pick which one ever looks easier. I think this blue one looks easier to me. It looks like it's less work. So I'm going to use the blue guy, and I'm going to say the distance to is equal to 12 times x, and we just found out that x is equal to 40. So I have to multiply. How much is 12 times 40? You can use a calculator. It gives you 480, and the units on this would be miles. So Rebecca lives 480 miles from the mountains. I know this can seem like a lot, and it can seem really confusing. If you have any questions, let me know. Remember, draw a picture, break down the information that you have. Take it a sentence at a time like we did. Go through the whole story problem and make sure you have all the information and that you wrote it all down. And then think about what they're asking you to do. Are you adding your distances together to find a total distance? Or are my distances actually the same that I set them equal? So let me know if you have any questions. Good luck.